This is Shakil Ahmed. In this tutorial, we will discuss about independent sample t-test in Excel. Independent sample t-test is used to compare the basically the means of two groups. The two groups are independent. For example, we have data of systolic blood pressure of obese patients or obese individuals and non-obese individuals. There are 18 individuals in group 1 and 18 individuals in group 2. So we just want to compare the mean systolic blood pressure in the two groups, whether there is a difference between mean systolic blood pressure in obese versus non-obese individuals. So we have a quantitative or continuous outcome, that is the systolic blood pressure, and we have a grouping variable, that is obese versus non-obese, and we obtained the summary statistics for group 1 and group 2, the mean and the sample variance and sample standard deviation. Before applying the test, we need to check the certain assumptions, whether these assumptions are fulfilling or not. And the first is the observations should be independent, as these are uh, different measurement from uh, different individuals. So these are independent observations, even within groups. And the second, the two groups are independent, as these are different patients. These are not paired data, basically independent data. We have 18 patients and 18 patients. Basically, we have total 36 patients. So these are all independent. So the two first assumptions are fulfilled. And the third is data are normally distributed in the population from which the two independent samples have been randomly drawn. And that is the normality assumption. The two distributions, the two groups are normally distributed. So the rule of thumb is that we can check just whether the mean is uh, greater than 2 times standard deviation or not. If you can check, this is the 2 times standard deviation is uh, 42, that is less than 132, and this condition is also fulfilled. So the two groups are normally distributed. Even though you can check using the QQ plot, or you can apply Calmegro-Simirno test or Shapiro test, that we will discuss in later lectures. But for now, we just assume that the data is normally distributed, as the rule of thumb says that the mean should be greater than twice of the standard deviation. And the third assumption is the two independent samples have been drawn from population with the same variances. We are assuming that the two variances are equal. So you can say that the sample variance is 452 and the sample variance for group 2 is 458. That is nearly close to the sample variance of group 1. So we assume that the two population variances are equal, and we will apply the independent sample t-test. So I will just show two methods. One, we can apply directly using the data analysis command, and the one option is we can do manually. For example, we have the means, and we can find the differences of the two means, and we can find the whole standard deviation, and then we can find the standard error, and then the t value, and then we can find the p values. So let's see. We can just find the difference in two means. This minus this, whatever you do. If our concern is the difference, just the two groups, whether the two groups are different or not. The null hypothesis, basically the two groups are same. So the alternative hypothesis is the two groups are not equal. The mean systolic blood pressure in the two groups are not equal. So now we can find the pool variance. How we can find the pool variance? Pool variance is basically the weighted variance, weighted average of the two variances, and the weights are the degrees of freedom. What is the degree of freedom for the group one? That is 18 minus 1. The sample size is 18, and here the sample size is 18. So we have degree of freedom 17 for each group. You can just compute 17 into variance 1 plus 17 into variance 2, and you can divide it by uh, 17 plus 17. You can just add 36 minus 2, that is 34. You can write just 34. So this is the pool variance between the two groups. And we, we now get the difference in mean and the pool variance. You can find the pool standard deviation, that is square root of pool variance, that is 21.36. Now you can find the t value. So t value is the difference in mean divided by the pool standard deviation. So pool standard deviation and steric square root of 1 over n1, that is 1 over 18 plus 1 over 18. You can write just 2 by 18. So this is the p-value. Even you can just check if this is not, if this is working properly or not. Uh, this should be divided by, this should be multiplied by whole of this. And this is the t value we get, the t statistics. You can again just confirm the values. We are using the difference in the numerator and the square root of standard deviation. If you are still confused, you can just add a bracket here. These all should be in denominator. So now the result is a little changed. We have now 4.8, 0.48. This is the t value. And make sure that we are using the pool standard deviation and 1 over n1 plus 1 over n2. So this is the t value, and now we can find the p value. How we will find the p value? P value is basically the region extreme to this value, greater than this value. As this value is positive, so we will find the although you can just find the t value for the two-tail test, p value for the two-tail test using uh, t distribution two-tail, and the x, that is this value, and the degree of freedom, that is 34. So this is the p value. We get for a two-tail test. So the H basically H naught is not rejected. H naught is accepted in this case. So we will just verify whether this result is correct or not using the direct command from data analysis command. Using data analysis and just Select the independent sample t-test with equal variance, and we select the range 1 from here, and the range 2 from here, and we have no hypothesis difference, that is zero hypothesized difference. And if you want to find uh, the output in specific place, you can just select. For example, I want to show the results here, so just click on OK, and then you can again see this is the t statistics, and the p-value, one-sided p-value is zero point 0.3 and two-sided p-value is 0.63, and this is the critical value of the uh, t statistics. So this is giving the same result as we get through manual calculations. So there is no significant difference between the mean systolic blood pressure between the obese versus non-obese. So same thing we can perform for log data. We have log data here, that is weight of individuals in treatment group patients, and weight of patients in control group, and we can just log transform of the variables, as most of the variables are become normal when we take log transformation. So we can just do the same analysis with the log transformed variables. And again, you can go to the data analysis option, and then independent sample t-test, as we are uh, we can check the conditions of normality and independent, and uh, the two groups are independent, so we can just select. Now we are selecting the first group from here, transform data, and we are selecting the second group from here, and we can change the output range here, and now you can click on OK. Now we see a little difference in the result. Now the result is statistically significant with t-value 2.42, and the p-value is now 0.02. So by taking log transform of this data, this data is statistically significant, and we can say that the weight of the treatment group and the control group, the mean weight of the treatment group and the control group is statistically significant. There is significant difference between the mean weight in the two groups. So this is the simple steps you can apply for your analysis for independent sample case. Thank you.